All right, so here's what's up. Y'all need to know this, so you should probably listen. Today, what I need from you to turn in, like what homework you are turning in, if you didn't do it last week, are these three that are still over here. That's why I haven't changed my board yet. So 421, 29 to 33, 422, 41 to 45, and 423, 50 to 54. Those were the three that we really did last week. We also talked about doing 424, but we never did. So this is today's homework. So if you haven't done, awesome, but you don't need to turn it in yet. I just need these three. Please turn those in by today or tomorrow, but today is your better option because tomorrow we don't have class. So please hear me when I say that you're going to forget. If you don't turn these in today, you're probably going to forget tomorrow because tomorrow is like a crazy day, really busy, full of activities. So please do it today. I do have more papers to hand back, but I'm going to get us started before I do that. So today, we're doing 424 together. Also, because it's really important content, and I didn't want to do it with only half of us here. Okay, because I feel like it's really important content beyond just the vocabulary acquisition of using the term constant of proportionality. It's good practice. So what I want you guys to do as pairs, I don't care if you work as a full like 4 group or not, but with whoever you're sitting next to, go ahead and look at question 455. Read through that and check out that situation. If you get done with A, B, and C, and you think like you've got those all figured out and you're comfortable with that, check out 456. But I'm just going to finish passing back papers and then we'll pull back together. So please make sure you have a header on your paper, which actually, if you just want to make your header constant of proportionality, that's fine. Just to get that vocab deeper in your head, you can just make that your header, and then dive into 455, please. We should all have textbooks out, at least one for each pair of us. So you shouldn't need my book up here, but I will put it where you want to, and then we'll pull us back together. Questions? Are we good? What page are we on? Somebody who's got the right page? 212. There we go. All right, dive in. I think it's maybe kind of homework, so
Yes, I turned those in.
you already turned them in, and that's good. That was probably just when I saw them and I put that on there.
Eat this.
Next time, so you just turn them all in, just kind of. Oh my God,
That's big.
Yeah, like next time, that's a check minus. Those three should be together, as in one. Like, always when I say like I'm collecting this, this, and this, or like those should be attached together. Because they shouldn't be attached while they're in your binder. They should just be in your binder. Isaac, why is 422 just sitting here loose? So guys, when you turn in homeworks, they should be stapled together, and we should be turning in all of the work that goes together. So like, where's your other ones, Isaac? Where's 421 and 422? Don't just turn in one homework when I'm collecting 3. And by the way, most of us are fine with this, but this folder stuff that is graded, please, if it's sitting here, just put your papers on top of it. That's like my sorting system. You always just put your papers in the bin. If it's in the folder, it's ready to go back to you. I'm going to flip these screens.
Get away from me.
So a table like T-chart.
Oh my goodness, people stop drawing on my book. People are drawing my book. Yes, I saw it open by
So this, like,
So one side of the T-chart will be hours, and the other side will be money that he makes.
people be November 18th, 19th. Okay. Represent a situation.
All right. So the first thing that we should remember is constant of proportionality is not new. We've already talked about it, but under a different name, which we could call alias, right? So if you have an alias is like your code name, your secret name, your like another name you go by. So like Joey might go by Joseph or Joe or Joey, but like he's all the same person, right? What else have we called the constant of proportionality? What easier name did we have? Unit rate. Thank you, Joe, Joey, or Joseph. So what we're talking about here is still the unit rate for these situations. So in 455, they tell us his unit rate, which is weird. They kind of tell us his unit rate. Can anyone tell me why I say in 455 they only kind of tell us the unit rate?
Because they didn't tell us fully.
What do you mean they didn't tell us fully?
Detail.
So I need everyone in your notes to write down the equation y equals kx. And we normally use a lowercase k. You didn't need to cross out your table, dude.
the heck?
Did I say cross out what you've done? Like that was dramatic. So, Nathan, why don't we have a pencil? And if you don't have a pencil, why don't we check my actual pencil complete? It's just behind Ava's art. So you probably need to sharpen this.
That's Desi.
Sorry, Desi. I'm so confused by why we're not trying to use a real pencil. No, because then you don't have an eraser. Nathan, when we come back from Thanksgiving break, I need to have 6 pencils in the pencil. So, this K is the constant of proportionality. Now, math does some weird things with variables. The reason we're using K is they didn't want to use C. So, K has that same sound for constant. And we can abbreviate this if we want. Constant of proportionality. So please make sure that we have that in our notes, that y equals something times x. That is our proportional relationship equation. And that k is going to be a number. So that constant of proportionality is always going to be some kind of number. Now, in 55, they tell us that Graham makes $4.23 for every half hour. First off, that's rather awkward. Second off, when I first see $4.23, I don't think that's very much, but then I see it's for every half hour. Can anyone tell me what we could do with that to make it easier to talk about what he makes, Ava?
So half hour is like 30 minutes. So
Yeah. Okay, does that really make it easier to talk about, though?
No.
I mean, telling somebody what they're going to make for every half hour is kind of weird unless they're going to work a half hour at a time. Eva?
Just turn it into hours.
So if we make $4.23 for 30 minutes of work, what Eva just said, or a half hour, then Eva told me, well, I can just turn this into 1 hour. How can I turn this into 1 hour? multiply by 2, right? So everyone multiply your 423 by 2.
You get 46.
We get 846. This is actually our unit rate because it is for 1 hour. The 423 is not a unit rate because it's for a half hour. A unit rate, also known as the constant of proportionality, has to be for 1 hour. So you might make a little note. And unit rate is also shorter to write. That once we have the for 1 hour, now 846 is where our unit rate is. So if we were trying to represent what he's going to make, we're going to say the y is how much he'll make or how much he'll get paid. We're going to say the x is the amount of hours that he works. What number goes here? What number will multiply by the hours that he works? The 8.46. That's how much we make every hour. So my y is going to be the money he makes. My x is going to be the hours he puts in. If he puts in 2 hours, we do 846 times 2. He puts in 3 hours, 846 times 3. Jalen, you got this with me? What are you doing over there? So then we want to make a table, right? We're asked to make a table for this situation. We know our constant proportionality is 846. We could have gone up by half hours, but that's weird. So if we go try to make a table here, we are going to make an XY table. So if you haven't done a T-chart on your notes yet, please do that. But we're going to go ahead and give a little bit more information. Y is my money, right? And X is my hours. What if Graham works 0 hours? He makes 0 money, right? That would be sweet. I would take that job. Ivan, what if Graham works 1 hour?
8.36.
Are you Ivan?
Ivan, you threw your voice really well. Are you going to be like a professional ventriloquist? I didn't see your lips move at all. Okay. Brendan, thank you very much. Not Ivan. If we work 1 hour, he's going to work 846. So Ivan, how can I figure out how much he makes with 2 hours? Yeah, multiply 8.46. So our equation to get y is 8.46 times x. Right? So if I do times 2, what do I get here? Anyone with a calculator, help us out. Yeah. Yeah, 16.92. That one, since we still did not break another dollar, that was still kind of easier, I guess. Do you have a calculator for the next one?
No, I did it myself. It's 25.38.
Sorry, what?
It's 25.38.
3.8. So, Brennan, I appreciate you asking the question of, like, why the weird cents or, like, who pays that. All of this is going to come, like, straight. These days, most pay is straight into the bank account. So people can get awkward amount of cents, and it doesn't really matter. Or if you don't have a bank account for it to go into, they might just hand you a check. Like, they're not giving you physical money. Normally, you don't get paid with, like, real money. You get paid with, like, a check, or they put it straight into your bank account. What if we end up at the end of the week, Graham was supposed... Actually, do you guys know how many hours are in a standard work week? That's a standard work day. You know how many hours in a work week? 40, right? 40 hours in a work week, actually. Let's say Graham almost makes it to that. He works 37 and a half hours. Because he cut a shift short. How do we solve for 37 and a half hours?
You do 4.7. 27. No, wait, no, you do.
Everyone get a calculator. Either you or your partner need a calculator. You or your partner need a calculator. You or your partner need a calculator.
How much is he making? Thank you. That's just
37.4.
The reason we're doing this is to make your life easier. We don't want to keep doing it manually. So I applaud all of you who are saying, well, I can do this in my head, I can do this in my head. But once we get to weird values, our equation is he will make 846 times however many hours. So we just plug in our calculator 8.46 times how many hours did he work? 37 and a half. What do we get when we do that multiplication? What do you have?
317.25.
Point what? No, that's before taxes, before whatever else he's paying.
All that coffee's gonna make it go down.
Yeah, so he will end up with less than that because taxes and everything else. Do we have this table in our notes? We have this. So if I walk around and check your notes, we all have this table with X and Y at the top, hours and dollars.
Yeah, come here and look. Dude, I've been up to 5
I want to be able to trust you instead of needing to walk around and check. Now, it then asks us to draw this as a graph. No, not this one. We're not going to do a graph for this. But if it asks us for a graph, what two things does the graph need to show since it's a proportional relationship? If I go to graph this and I draw my x-axis and my y-axis, this is money, this is hours. What does my graph need to look like? What two things did we say is necessary? Straight line through the 0, 0. So this is my start point, right? $0 for 0 hours of work. And then it would need to go up straight. So the graph would need to look something like that. Questions? Now 56 still does not give us the unit rate. I want you and your partner to try to figure out what the unit rate is. So go ahead and write down the info 56 does give us. So number 56 on your paper. And we're going to write down 9.3 miles in 1.5 hours. If you can't remember how to find your unit rate, check back in your notes from last week. So I'm going to give you probably about 5 minutes to work on this. We want to make a graph of this data. We also want to find the constant of proportionality, which is also the unit rate. Last week when we talked about the math, we did it with unit rate. And then check, is it proportional? Okay, so I'm going to give you at least 3 minutes, probably about 5. You and your partner talk about this. If you can't remember how to find the unit rate, go back in your notes and see if you still have that written down. We can just turn those off. You're at school. You should probably just leave those off.
Did he run those 9.3 miles?
There are multiple ways. We essentially want his speed per hour. Oh, Jamie. Sorry, she. Jamie.
Wait, that's really fast.
Whose pecans are there? Be careful those two have. You really shouldn't be bringing How far can she run in 1 hour? Can we remember how to find our unit rate?
Okay, it says make a graph. I'm gonna do it. There's one.
Do you remember how to calculate our unit rate? Do you remember how to do it, guys? There's a division that we have to do here. You are absolutely correct. So, I don't ever normally put punctuation on what I write on the board. I think I was more so thinking like hours gets a period because it's abbreviated. I don't normally put any punctuation at the end. Sometimes I do question marks, but you're absolutely right. If I put punctuation, it needs to be a question mark because it's not abbreviated.
Now I don't know how to actually calculate it. Just because Gabe knows that.
We want one. So is the unit
Questions?
No.
I'm going to use cards. Sophia,
Hi.
do we remember what division we need to do to find our unit rate, which here is miles per hour? What do we do?
I did it divided by 3. 9.3 divided by 3.
Okay, then what'd you do with it?
I times it by 2.
You are absolutely correct, but you worked too hard. Sorry, what you did is absolutely right.
No, I like what it gave you too hard.
It can be easy, right?
By 1.5.
No. Nathan. Think about what you want, guys. So, what made you decide to do that division? You don't know? Jalen told you? Well, that's a good reason. I would trust Jalen. Brandon?
Because 1.5 divided by 1.5 hours is 1 hour. And then whatever you do to hours, you have to do to miles. And if you divide 9.3 divided by 1.5, you would get 6.2.
Guys, what we want here is miles per hour. What does per tell us to do? Divide, actually. Be careful. Of is multiply. Per tells me to divide. So I need to take miles and divide by hours. So we set up 9.3 miles over 1.5. Now, here's what Brendan just walked me through. To turn 1.5 into 1, we have to divide by 1.5. But all we really have to do is this math. It is set up for us in the fraction. So if you haven't done this yet, type into your calculator 9.3 divided by 1.5, and we should get 6.2, which means our speed is 6.2 miles per hour. Now, but that isn't even where we were headed. You were supposed to make a graph of this.
I did that.
Right, so we go to make a graph.
10 by 10. I did 5 by 10.
Actually, if we make a graph on graph paper, so guys, this starts to get particular. I need your attention. And I got some of you halfway here. It's a short week. I can tell some of you are just like, your head is in the clouds, and I got to bring you back. When we graph this, guys, there's still like 5 people talking. When we graph this, the x-axis and the y-axis tell us what is what. What labels are the y in this situation? Or you can ask yourself, what is my input value that changes things? Riley? So speed is miles per hour. That uses 2 different labels, right? So I can't really have speed, like I can't use 2 labels on my graph. I gotta put one somewhere and one the other where. So where do I put miles and where do I put hours?
Hours is on the line.
Hours is down here.
Oh my god, I wrote it right on this, but you confused me.
So here's what I need you guys to write in your notes. Time is almost always in the x. When we're working with time, time is almost always the x variable.
When could it be in y?
You got this down? Y then, here, not speed, distance, how far we went. If I go to 1 hour, what should my distance traveled be? 6.2. So do you think I'm going to go up 6.2 boxes? Not if I want to make my life easy. I'm going to force it. I'm going to say that 1 box, if I'm making the scale, I want to make my life easy, right? I can make a point right here so that this has to be 6.2. Then if I go to 2 hours, how far should I have run? 12.4. 3 hours, if I put another point here.
And then 18.6.
Ooh, 18.6. And then we can draw our line. That's not a very good line. I'm going to cheat, get a better line.
Time stop.
Guys, I have some of us just sitting there doing nothing. Stick with them. I lose you, and then I bring you back, and then I lose you. Careful. So if you make 1 box 1, you can't then make 2 boxes 1. You know what I mean? So if you want to make a scale of 2, you got to start it from the very beginning. You got to go 2 boxes out before you get to 1. Guys, we should all have this line on our paper or be raising a hand to ask for help. Yeah.
What's the point of having connections second
We just moved the schedule because the different the guest teacher that's here today and who wanted the time. I don't know exactly. I was just adjacent to the text messages saying this is what's gonna happen.
Wait, so it's gonna connections gonna interfere with like I like then global cultures, so it's like gonna be connections for 2 classes.
I'm not sure.
No, connections is that. So just yell it inside.
Hey, Mr. Smith, any chance you want to jump in and help him work through 57? And I'm going to have a conversation really quick with someone. Check out 57. I'm going to have Mr. Smith fly the plane on this one. I'll be right back.
Starting with the egg, what's your grade for your partner? You got cookie bacon. 2 batches. Shiloh needs to make multiple batches though. have an equation. Okay, so we've had a few minutes to at least start to be figuring here. How many batches has Shiloh made in the intro sentence there? 2. And when there are 2 batches, how much flour do you use? 2 batches needs 2 and 2/3 cups of flour. So what do we need to do to make this a constant of proportionality? How can we find our U rate? Oh no, are you serious?
It really hurts.
You gotta divide 2 divided by 2 over 3.
Wait a moment. Yeah,
You gotta divide the number of batches by the number amount of flour. Do we want?
Wait, isn't it through 11?
Is that what we want? Do we want batches per flour?
No. No.
What would make more sense?
Decimal.
Okay. So, Labiba, help me out there. We could figure that out. We could figure out how much batches per flour. But Labiba says it makes more sense to have the amount of flour per batch as opposed to batches per flour.
Yeah, that's right.
When you say it out loud, that makes more sense, right? Because we want to make a batch of cookies. So we want to know, this is still kind of ugly. If, guys, if we look at this mixed number over a whole number, you got enough time as long as we solve this problem correctly. So, can we do this in our head though? Can we divide it without having to go through the whole making this an improper fraction? And flipping?
0.75.
Keeping
0.75.
I need eyes up here, mouths closed. Looking this way. If we just take the 2 cups of flour to start with, what is half of 2 cups?
1
Natalie, stop. What is half of 2 cups? 1 cup. What is half of 2/3? 1/3. Half of 2/3 is 1/3. Now, this is also as a decimal what? 1.3 repeating. Okay. So,
Are we supposed to be doing 2 divided by
2.6666 divided by 2. So does anyone have an equation? All right, Kevin, what do you got? Okay, and I'm going to call them B and F for this, okay? So, Kevin says talking batches and flour. But he's correct. And X and Y would be fine as well. So we've got the situation with an equation. What is the constant of proportionality? 1 1/3. The constant, thing that's not going to change, no matter how many batches, is this number. Okay? So, the constant of proportionality, correctly identified by Joey as 1 1/3 or 1.3 repeating. How can you use an equation to determine if a relationship is proportional? What do we know would have to happen if this was proportional? If it was proportional.
0, 0.
What's one thing?
0, 0. It has to start with 0, 0.
It has to multiply. Yes. I think there's a little bit more description needed, but you're right. And I heard at the same time, there's also that whole 0, 0 thing. So, before we even get into multiplying like Ava wants to do, which is correct, let's real quick double check with what Riley said. If we make 0 batches of cookies, how much flour do we need?
0.
So 1 1/3 times 0, so we will get a 0, 0 point. Now the other thing that Ava said was that whole multiplying thing. So, if this is true, and we want to double check, make sure it's proportional, what would, something we could punch in the calculator, maybe, could we check it with something? Maybe another number of batches? 17, we could calculate the number for 17 batches of cookies. We can make it a little bit easier than that, I think.
2.
So 2, and that was from the question. Does that work though? 2 times 1 1/3 will get us there. And let's do one more. What if we use 3? How much flour would we need for 3 batches? How do we check that? It's 4.
So
Because
Mr.
what did you
Smith?
do?
I have a question.
Okay, so you broke it down.
I think your B and F are switched. I think it should be F equals 1 1/3 B. Right? Isn't flour your output?
2 2/3 cups of flour. Make batches of cookies. So 1 batch is 1 1/3 cup, right?
If F is the amount of flour, then B should be like 1, 2, 3. Like your table's right, but your equation doesn't match your table.
You're right.
Hey, so we're gonna say we did this on purpose, but that's a lie. Mr. Smith made a critical error that is exactly what I see 7th graders do. So we're gonna play it that he did it on purpose. Ivan, do you know what we're gonna say? His table's right. Everything he said is right, but his equation actually isn't.
Oh my god.
Layla?
The F and the B should be switched.
The F and the B should actually be switched. Now, this is the dangerous part about when you start changing, like when you don't use Y and X. What we're actually saying is the amount of flour needed. Right? So when we go look at this problem, we say the flour that we need, F, will equal 1 1/3 times the number of batches we decide to make. My lowercase b's often kind of look like 6s, so I'm actually going to use an uppercase B. However many batches we make, that determines how much flour we need. Who's baking or cooking something for Phoenix Fair? Or like thinking about it? Or who's ever baked or cooked something? Okay, that helps more. So you know that as you add more or make more, hold up, we need more of it. Hold on, I got a good story. So you can start packing up if you want. But if you do not follow proportions, things can get really wrong really fast. You guys want to hear an embarrassing story about me?
Yeah.
So cooking has a lot of proportions in it, and there's a proportion related between teaspoons and tablespoons. There's a certain amount of teaspoons that make a tablespoon. A tablespoon is bigger than a teaspoon. Anyone know how many teaspoons are in a tablespoon? I think it's 3. It's awkward. I think it's 3. I accidentally used a tablespoon of salt instead of a teaspoon of salt and had way too much salt. So what I had to do is go back and triple everything else because of how much salt. Is it 3? Yeah, I had to triple everything else. I was making guacamole. So I had to go buy more avocados. I had to go buy more limes. I had to triple everything else. So have a great day, guys. I tripled my salt, so I had to triple everything else. Huh? Yeah, but I misread the recipe. I thought the recipe called for tablespoon, but it was a little too, not a big, I was moving too fast. That's what happens when you're moving too fast. I put a tablespoon, it called for a teaspoon, but a tablespoon is 3 teaspoons. Right, that's like your conversion factor. So yeah, it was not good.